So chapter 4, this is volume of revolution. So first, integral x cos 2x dx. So here, this is by parts. So repeat. X is polynomial, cos is trigonometry. So x equals v, u, cos 2x becomes u prime, v prime. Then u prime is 1, u prime is 1, and v prime, v equals sine 2x over 2. So now this is a u v prime. So now u v minus u prime v. So u v x 2 sine 2x minus integral u prime v sine 2x over 2 dx. So x sine 2x over 2 plus cos 2x over 4 plus c. Number b. This is 2x 1 over 2 sine x. So here revolution 2 pi radian around the x-axis. So 1 full revolution. So volume of the solid from 0 to pi over 2. So pi y squared dx. So 4 0 pi over 2 x sine squared. So sine squared again, cos 2x is 1 minus 2 sine squared of x. So sine squared of x is 1 over 2 minus cos 2x dx. So here 2 pi n integral 0 pi over 2 x minus x cos 2x dx. 2 pi 1 over 2 x squared minus, we found x sine 2x over 2 minus cos 2x over 4, 0 to pi over 2, and you can calculate it. Number 2, integration by parts. Show that x, so x secant squared of x repeat. So the left side is u, the right side is v prime. So x is polynomial, secant squared over x is v prime. So u equals x, u prime equals 1, v prime equals secant squared of x, v equals tan x. So here, this is u, so integral u v prime becomes uv minus u prime v. So now we have uv x tan x minus integral u prime v tan x dx. 0 to pi over 4, 0 to pi over 4. Pi over 4 minus 0 minus tan x. Tan x, do we know this or do we need to? Just let's go. Pi over 4, 0 sine x over cos x dx. Let cos x becomes w, then dw over dx becomes negative sine x, dx becomes dw over negative sine x. X equals 0, w equals 1, x equals pi over 4, w becomes square root of 2 over 2. So continue. Pi over 4 minus 1 square root of 2 over 2 sine x u dw over negative sine x. Pi over 4 plus ln w, 1 square root 2 over 2. Pi over 4 plus ln 1 over square root 2 minus 0. So pi over 4 plus ln 2 negative 1 over 2. So pi over 4 minus 1 over 2 ln 2. And this is what we show here. So yeah, you will figure it out. So this is just a 2 mark. Integral pi y squared from 0 to pi over 4 dx. So pi 0 to pi over 4 x sec squared of x dx. So just we multiply pi here. So pi squared over 4 minus pi over 2 ln 2. Number 3. Tangent T to C at 1, 3 meets x-axis here and blah blah blah. So region rotate 2 pi radian about x-axis. So now when we rotate here, let's say, so here we make this it look like a funnel, but it's like much larger, and we dig emptied inside with this like triangular, like a cone shape. So exact volume of this solid. So let's do that. So for example, just in the middle of for the cross section, in the middle of the here, we will find one washer here. So the volume of this washer, we have the base of the like circle, but like with hole. So the larger radius is this one. This is larger radius, which is the y of this curve, x plus 2 over x squared, pi r squared minus, and smaller r equals this one. So pi, and the radius of the equation of this tangent, y equals 1,3 to 5 over 2,0. So 5 over 2 minus 1, 0 minus 3, 2 over 3, 3 over 2 minus 3, negative 2. So negative 2, x minus 1 plus 3, negative 2x plus 5. So negative 2x plus 5 squared, integral from 1 to 5 over 2 dx. Calculate it, then you will find the answer. And number 4. So here, rotating around about the x-axis. Okay, so here, from here to here, sine and cosine, when they are same, secant of x minus cos x becomes cosecant x minus sine x. So cos x, 1 over cos x minus cos x, 1 over sine x minus sine x. Let's multiply sine x and cos x. Then sine x minus sine x, cos squared of x, cos x minus sine squared of f, cos x. So here, sine x, 1 minus cos squared of x, cos x, 1 minus sine squared of x. So here, sine cube x becomes cos cube x. Tangent cube x becomes 1, therefore x is pi over 4. So here pi over 4. Yeah, but actually it looks very symmetric. Okay, anyway. So integral 0 to pi over 4 pi sec x minus cos x squared dx plus pi over 4 to pi over 2 cosecant x minus sine x squared of dx. So this one pi 0 to pi over 4 sec squared of x minus 2 plus cos squared of x dx plus pi over 2 pi over 4 cosec squared of x minus 2 plus sine squared of x dx. So secant of x is tan. So 0 to pi over 4 plus a minus 2x So here negative 2x plus cosecant squared of x, also negative cotangent x minus 2x pi over 2 pi over 4. And now we have cos squared and sine squared. Cos squared is from the cosine double angle identity. Cos squared of x becomes cos 2x plus 1 over 2. So 1 over 2 cos 2x, 1 over 2 sine 2x plus x. And this one between 0 to pi over 4 and sine squared over x, 1 minus cos 2x over 2. So plus 1 over 2 and x minus sine 2x over 2 and pi over 4 pi over 2. So this is what we need to do. So shall I continue? Okay. So pi 1 minus pi over 2 0 0 minus 0 minus pi minus 1 minus pi over 2 plus 1 over 2 sine pi over 2 plus pi over 4 minus 0 0 plus 1 over 2 pi over 2 minus 0 minus pi over 4 minus 1 over 2. So here pi over 4 we have no anymore, so we don't have it. So here pi 2 and 1 over 4 1 over 2, so 2.5 and minus pi plus pi over 4 minus 0.75. Where is 0.75 pi? So 2.5 pi minus 0.75 pi squared. You can check the answer. I don't know. So now let's go to the revolution over the y-axis, about the y-axis. So here. So let's rotate it here, like here. Then we make it like this. So when we rotate it here, the radius is x. So integral 2 to 4 pi x squared, because the radius is x. So e to the power of 1 over 2y minus 2 squared of dy. So now you can do that. So let me go further. Number 7. So here area is just so this is parametric equation. So between 1 to 9, an area of region R. So let's do that. So T So here T equals to the square root of x minus 1. Because T is between 0 to 2, so square root of x cannot be negative. So let's put it here. Y is 1 over 2 square root of 2 minus square root of x minus 1 cube plus 3. So integral 1 over 2 square root of x minus 1 cube plus 3 between 1 to 9 dx. 1 to 9, 1 over 2 x 3 over 2 minus 3 x plus 3 x 1 over 2 minus 1 plus 3 dx. Then you can do that. So here about the x-axis, integration to find the exact volume. So here. Now let's make it as it is, like as this parametric equation. So generally we need to make integral pi y squared of dx. This is what we need to put. So d of x over dt becomes 2t plus 1. So dx becomes 2t plus 1 dt. So x between 1 to 9. So when x equals 1, t equals 0. When x equals 9, t equals 2. So 0 to 2 pi y squared. And dx 2t plus 1 dt. You can expand it and you can integrate it. And number 9, proof. Sine cube theta is a sine theta and sine squared of theta. Then sine theta 1 minus cos squared of theta. Then sine theta minus sine theta cos squared of theta. Then sine 2 theta. Let me make something else. Let me start from the right side. 3 over 4 sine theta minus 1 over 4 sine 2 theta plus 1 as theta. Then 3 over 4 sine theta minus 1 over 4 sa ko pu ko sa, like this. Then 3 over 4 sine theta minus 1 over 4 2 sine theta cos squared of theta plus, again let's go for the sine. Then 1 minus 2 sine squared of theta, sine theta, like this. Then cos squared of theta is 1 minus sine squared of theta. So 3 over 4 sine theta minus 1 over 4, 2 sine theta minus 2 sine cube theta plus sine theta minus 2 sine cube theta. Am I correct? 2 sine theta, 2 sine cube theta. So here, now we have 3 over 4 sine theta minus 1 over 4, 3 sine theta minus 4 sine cube theta. So now we don't have it anymore, and sine cube theta. So the diagram shows the ball looks like this, and rugby ball length of 30 and height of 20. So here 15, here 10. So curve C has parametric equation 15 and 10. Okay, the rugby ball is modeled as the volume of revolution rotated by 2 pi radian about the x-axis. Okay, so here negative 15 to 15 pi y squared of 2x dx. So we will find this one. So pi integral, because this is x, so let's find the theta. So negative theta means negative pi. Negative 1, negative 15 becomes 15 cos theta. So cos theta is negative 1, means pi. Sorry, not negative pi, pi. And 15 equals 1, so 0. So y squared is 100 sine squared of theta, and dx becomes 15 negative sine theta d theta. So here negative sine theta, so now we have sine cube theta and 15 d theta. So 1500 pi integral 0 to pi, because now we have minus, so we can change the boundary. So 1500 pi from 0 to pi sine cube of theta d theta. When sine has like this cube, then we can separate it 1500 pi 0 to pi sine theta and sine squared of theta d theta. So here 1500 pi 0 to pi sine theta 1 minus cos squared of theta d theta. 1500 pi 0 to pi sine theta d theta minus 0 to pi sine theta cos squared of theta d theta. So the first one is just normal integration. So negative cos theta pi to 0 minus this one, let's u becomes cos theta. Then du becomes negative sine theta d theta. And the boundary, when theta equals 0, u equals 1. When theta becomes pi, u equals negative 1. So sine theta times u squared times d theta is negative sine theta du. So we don't have it anymore, and this can be plus. So 1500 pi negative cos theta minus 1 plus 3 u cube over 3, 1 to negative 1 So 1500, 2 plus negative 1 over 3 minus 1 over 3. So 1500 pi times 2 minus 2 over 3. So 4 over 3. So 2000 pi. So I think the volume, exact volume is 2000 pi cube centimeter. And number 10. Now we have this outlier. Outline of the solid glass. Pendant 0 to pi over 2 and blah blah blah. 2 pi radian, estimate the volume of glass. So integral, now because this is rotate about the y-axis pi, x squared of dy, and when x equals 0, because we need to know the boundary of y, when x equals 0, pi start at t from 0 and pi over 2. So this is pi over 2 make it y. So 0, 4, pi over 2, 0. So this is the 0 and 4. So now pi, so this makes the boundary of t when t equals 0, y equals 0, t was pi over 2, and 4, t equals 0. So x squared, 4 sine squared over 2t, and dy becomes a negative 4 sine t dt. Negative 4 sine t dt. So negative 16. So let's change the boundary, pi over 2. So sine squared of 2t, and y has sine t. So let's make it consistent. So sine double angle, 4 sine cube of t cos squared of t dt. So 16 pi, 0 to pi over 2, 4 sine 64. Let's make it 64. When you have the odd power, just separate one, and sine squared of t cos squared of t sine t dt. Because of this, now we understand substitution, u becomes cosine t. So 64 pi integral, when t equals 0, u equals 1. When t equals pi over 2, u equals 0. And this one, sine squared of t is 1 minus cos squared of t and cos squared of t. So this one is a u squared minus u to the power of 4. And du becomes negative sine t dt. So here negative du. So 64 pi, again, change the direction here, boundary, and u squared minus u to the power of 4 du. 64 pi u to the power of 3 over 3, u to the power of 5 over 5, 0 to 1. 64 pi, 15, 2. So the answer is 128 pi over 15.